You may recognize this consumer device. It's used to measure voltage, current, frequency, and the power consumption of devices in your home, with the hope that you can reduce energy consumption. You could think of it as many pieces of test equipment all in one. You have a current meter, a watt meter, and a voltmeter. It provides readings for current, voltage, real power as measured in watts, and frequency. You see those on the top here: volts, currents, power in watts, and hertz, which is frequency. It also does what I would call derived calculations, and these are for the apparent power and for the power factor. I'll circle those here as volt amps and power factor. It also has memory, which it can use to calculate the energy consumption of your appliance. For this video, we're going to focus in on what I called those derived calculations. That's the apparent power and the power factor. For apparent power, consider the voltmeter and current meter in this circuit. What we do is we multiply those two readings together. Again, the product of voltage and current is a volt amp. That is called apparent power. We're going to use the symbol S for apparent power. And here we see that the magnitude of the vector S is the product of voltage and current. Again, this is a scalar. A scalar has magnitude but no direction. But something you must remember is that real power will be less than or equal to apparent power. If you have a pure resistive circuit, they will be equal. If you have anything else, like an RC or an RL circuit, real power will be less than apparent power. We can think of this as a triangle, where we put real power on the base and apparent power on the hypotenuse. Turns out that it's reactive power off to the side, and we'll put angle theta here. As far as units are concerned, we have the vector S as apparent power with units of volt amps. We have Q for reactive power with units of volts amps reactive. And on the base, we have P for real power, which is measured in watts. Again, S is a vector. It now has magnitude and direction. Here's an example. Let the absolute value of the voltage be 120 volts. Let the absolute value of current be 4 amps. And let the real power be 400 watts. Now, a meter would read 120 volts, and a current meter would read 4 amps. When we multiply those together, we get apparent power, which is 480 watts, which is greater than the real power of 400 watts. When we construct our triangle, we put 400 watts on the base, 480 volt amps on the hypotenuse. Using Pythagorean theorem, we can solve for 265 volt amp reactive for the opposite side. And then we can solve for theta using a little bit of trigonometry. That works out to about 33.6 degrees. If you're using your calculator, you could have put these numbers in and then done a rectangular to polar conversion. Moving on to power factor. Well, it turns out we already did calculate power factor because power factor is defined as the cosine of theta. Finally, we can talk about energy, where energy is equal to power times time. We have to be very careful here to remember that when we talk about power, it's real power. Please leave a comment below if you have any questions or suggestions.